Shoving the notes in your face here, kind of like the classic illegal lesson these days, teacher's direct instruction, but I'm worried about just you being ready and hopefully this spurs some memories. So actually the first thing you should write is my writing up there, that 1/2 plus 1/3. So I will be honest with you, and I know a lot of students don't want to believe this, but that question should be as hard as the first example that we're going to do for the day. True statements. Because when I add fractions, I need to get a what? Everyone say it. Ooh, you might be able to hear yourself on YouTube for millions. All right, so 1/2 plus 1/3. Sometimes the common denominator is as simple as, hey, this has a 2 in it, and this has a 3 in it. This one I need to get a 3 in it. So I multiply top and bottom by 3. Why top and bottom? What's 3 over 3 the same thing as? 1. So I've not changed its numerical value. I've just changed the way it looks so that I could have a common denominator. 1/3's got to be multiplied by 2 over 2. Then the last Mickey Mouse grade school thing. Add the numerators, but put them over a common denominator. What screws up the Algebra 2/CAT student is usually the grade school concepts, not following through those, let's call them rules, that we should know like the back of our hand. So when I look at this first expression that I have to add, let me just sink back a little bit. I have to assess what's the common denominator, and of course it's just slightly more complicated. So you can read all this writing the steps. That's for you. And I'll give you a second to write that down, I guess, if you're a classic note taker. So note takers, you're done. Note takers, I let them take those words down if they wanted. We discussed them a little bit more. So let's look at and zoom in on example 1. And again, if you want to answer out loud when I ask these, fine. If not, I just want to get through these notes. But what you have to understand is when you have binomials, binomials are their own entities. You cannot break up n and minus 1. N minus 1 are stuck together, just like n minus 5 is stuck together. So this n is not the same as that n. So what is the common denominator? N minus 1 times n minus 5. And then I'll tell you what you should do on a test or a quiz tomorrow. This is missing a what? So I have to put it in both top and bottom. What is it missing? N minus 5. Just like the other one, without variables, you had to multiply by 3, I think, the first fraction. Or it was 2. I forget which one was which. So what is this one missing? And then I know I'm going to use the commutative property constantly today. These are switched around, but they are exactly the what? Same. Commutative just means you could have a multiplication statement written A times B or B times A, using different letters. So what do you have to do next? I get a bunch of crazy stuff. Some people are all proud of themselves. They get this first step. Then they start convoluting math completely. Like, oh, well, look, now I can cancel that. And now I can cancel. I shouldn't even show this. This is infinitely bad. What you have to do is simplify the numerators. And then put that simplification over a common denominator. Never multiply out the denominators. So now here's the common denominator. Just like 3/6 plus 2/6 is 5/6. Well, this plus this is all over one common denominator. That's how two denominators become one. Then what you have is minus 5n. Be careful on this. If this was minus, what has to be distributed? Not just 4, but negative 4. That is one of the biggest mistakes ever made. My ends are getting bad here. And then you keep going and you add the numerator, or you combine like terms. And then this is step 4 from the writing. Does the numerator factor? You should ask yourself that, but does it? Does anything multiply to negative 4 but add to negative 1? No. So you're lucky that you're done. That is the adding of those two fractions, going through the grade school process, but through Algebra 2, I will call that. Definitely something in Algebra 2 you did a lot last year. Chapter 8, that was a biggie. Okay, next one, and then I'll stop for questions at the end of this one. Again, just teaching formally, so we're fast here. When you get a common denominator, it actually does require that you factor. Okay, so you got to get every denominator factored before you can assess that. So what is that in factored form? What can we take out? An n, and what are we left with? N minus 2, good. Some people like drones are answering the question. And then what is this in factored form? So it's a perfect square difference situation. Said that kind of out of order. So you really got to know how to factor and factor fast. So we got to know those tricks. And if it helps you just to get rid of that so you don't have to see the unfactored, go ahead. All right? Now, what is the LCD of these three fractions? N, good. What else? N minus 2, good. What else? N plus 2. The way you look at it, this has an N, this has an N. Oh, this doesn't have an N. So guess what? You're going to multiply this by what? N over N. So this has those three things. This only has two things. So what is this missing? N plus 2. This is the way I do it. I just make sure all the denominators are the same by using the rule of 1, I guess I'll call it. Multiplying by a form of 1, both top and bottom. Then I'm going to blow your mind on this one. What is this missing? What's this middle one missing? N what? Minus 2 and what? But do you know what n minus 2 times n plus 2 was? So it might be smart to just go ahead and throw that in multiplied form. And then we've taken care of it. So I know this looks like junk, but I don't think, this is review. And I hope through these memories you remember, this stuff that we did. So what I'm going to do next is start distributing and simplifying the numerator. Just understand that this denominator is n plus 2n minus 2n, n plus 2n minus 2n, n plus 2n minus 2n. All three denominators are exactly the same. So when I go ahead and add the numerators, almost took a spill there, n times n minus 2 times n plus 2, I just go ahead and reorganize them. Commutative property. Then I start doing this. 2n plus 4. This is, since I made my life easy, I don't have to FOIL anymore. I already FOILed that out. And then I distribute that one. By the way, that's a plus. Whew. If it was a minus, I'd have to distribute a negative one. So this is n squared minus 4. And then this last one, this is a minus. Make it plus a negative, but it really just is negative 3n. So it didn't require distribution, even though I'm hammering down that idea. Distribute a negative if it comes to that. Now that ain't so bad. Is not so bad. Let's do English good. Do English good? Is that good too? I don't know. The numerator, you want to simplify. N squared? Okay, no other friends. 2n and negative 3n? Minus n. Done looking at them. 4 minus 4. Nothing. You're at step 3 of our words up there. The last thing is, does the numerator factor? What's the answer to that question? Yes, darn tootin' it does. And what's the value of doing that? Or what happens now? Now things cancel. So this cancels. Before I cancel, though, I should talk about domain again. And actually, the domain still sits right here, even from the original. What can't n equal? N can't equal what, everybody? 0, what else? Positive 2, and what else? Shouldn't be an issue. Okay, so the final answer, I'm going to be lazy. I'll draw my circle right around there, getting rid of those canceled out factors. Believe it or not, it's the same thing as when you have 4 over 8 as a final answer. It's not a final answer. 4 over 8, the 4's cancel in both the 4 and the 8 to become 1 over 2. So that's what's happening there. Okay, now we look at what's called a complex fraction, which is a fraction within a fraction. And I'm going to show you 2 different ways to do this question, and really you can pick one. I could, as a teacher, just show you one and just focus on that, and then everyone would be the same. But I want to have you make the choices. And actually, if you get really good with math, sometimes, like me, one of the ways is better for certain types of questions compared to other types. But you probably won't get there yet. So maybe right now, make a pick. So what I'm going to do is the first one, using what's called the first way, which is turning the question into one that you actually had yesterday. So as you're maybe writing this down, what operation is this big fat bar right here? What operation is that? So that's what you do. You turn this into a division statement, but before you do that, you have to individually simplify each numerator, the numerator, and the denominator. You got to turn it into one fraction, each one of these. And how you do that is how we just did it in the previous two examples. And then we're going to turn it into a yesterday question. So that's what all this rigmarole up here says. So what I'm going to do is zoom in on this and show you that. So, but I will ask you a question. This is 3 over 3 over 3 over 1. So what I have to do is take this red and turn it into one fraction. I'm doing this on purpose like this to really designate the notes here and really show them out loud. So what is the LCD of the red? What's the LCD? Just x plus 2. It's not a big deal. So how do I get a common denominator? Well, this is fine. What do I have to multiply this by? An x plus 2. And then what we'll have after this, I'm going to distribute and add the numerator. We will have this as one fraction right off the bat. And I got to zoom back so we can see this maybe down here. 3x plus 6 minus 7. What's plus 6 minus 7? Minus 1. All over the common denominator, x plus 2. And now what I've accomplished is I have one fraction. Step 1. Within step 1, part B, do the same for this one. This is, keep going, 1 over 1. I got to lasso this like a cowboy here. Yeehaw. All right, get that out of the way. 1 over 1 minus 1 over x minus 3. What is the LCD of the green? What's the LCD of the green? Just the green. I haven't heard anyone. It's x minus 3. So what's this missing? Say it again. And then what I have now is a common denominator. And then I'm going to zoom back so that I can write that down here. One more zoom back. And then the numerator is 1x minus 3 minus 1. What's minus 3 minus another 1? Minus 4. Okay, so I don't know if I'm over-explaining this. It probably is worth it, though, because this is one of the student stumblers, we'll call it. I like that, a student stumbler. Can't lasso that like a cowboy. Oh, well. All right, so I'll zoom in on a little bit, but then I'll move down. Okay, so then what do you do next? You treat this, no, you actually treat this as a what? Division. Now I'm going to overwrite this. 3x minus 1 over x plus 2 divided by x minus 4 over x minus 3. Now, always in your student work, you could probably skip a couple of these steps. I'm trying to over-explain this so you understand what's happening. How do you deal with that division statement? What do you do with it? You multiply, flip. And then sadly, this is very sad for me because it's one of my favorite things to do. Sadly, what doesn't occur? Nothing cancels. So that's the final answer. Usually something cancels after all of this. Now, going back to these domain issues, which you're probably sick of hearing about, but you can look at the original. You know in the original, x cannot equal, what can x equal? That little thing I'm denoting right here. Negative 2, what else can't x equal because of this little denominator? Negative 3. I'm sorry, 3. You didn't say negative 3. And then still all of that, x can't equal 3 or negative 2, but now what else can't x equal after the flip? 4. So it's before and after you do the domain issues. Okay, and then one more. You just heard the bell, so we're not even halfway through. So I'm going to stick to the whole giving you like 20 minutes for your homework here, whether it be legal or not. I want to help you out. The other way is it kind of really works well for this kind of question. when your denominators are all little monomials. Another way to attack these is get the LCD of all the little fractions. And then you could read, multiply by a big Godzilla LCD of all the little things. So, and then we'll go from there. And what that does is get rid of the little fractions, and then you'll see. We could still do this one like the last one. We could turn this into one fraction, turn this into one fraction, and then flip, divide, flip. But I'm going to show you the other way in case you like it. So what is the LCD of all the little denominators? A squared, B squared is correct. That covers everything. So what do we do next, though? This is unique compared to the last example. We multiply by a squared, b squared, the whole big fraction. So what I always do when I teach this is I show it like this, to really denote that since the numerator has a fraction in it, I write this a squared, b squared over 1. And then I put it over in the denominator, too, a squared, b squared over 1. First of all, this still equals what? What does this equal? What does that equal? 1. So you're multiplying by a form of 1. Second thing, when I distribute this, I'm going to overwrite this again, but I would hope you would skip this next step. These a squared, b squareds go in the numerator of the small fractions. How you multiply fractions? You multiply the numerators and multiply the denominators. That's why I wrote an over 1, so that you understand 1 gets multiplied by a squared. So this turns into a squared, b squared over a squared minus a squared, b squared over b squared over. Distribute that a squared, b squared over a minus a squared, b squared over b. And I would hope at some point you could skip that step, because the whole point of you doing this is who cancels in this first little fraction? Who cancels? And then what's left is a b squared in the numerator. So mathematically, I'm going to write this as a big fat b squared now, right in that position, because it's b squared over 1. So what I did is I got rid of the little denominators. Who cancels here? B squared. So I'm left with a squared. Who cancels here? Just a what? An a. So this is ab squared minus a squared b. All right, I know what you're saying. Ugh. What's the point of all this and all that other stuff? Well, it's some good algebra. If you can get past this algebra, then you can proceed on to more complicated math concepts. But wait, there's more. It's like the infomercial that will never end. What can I do with the numerator? You can definitely factor. What kind of factoring is this? A difference of two perfect squares. So what does this turn into be? B. Oh, I was going to do minus a. Uh-oh. Now what do I have to do? It's no big deal if you do minus or plus first. How about the denominator? What kind of factoring can happen in that one? You can pull out more than an A. Good start. You can pull out an A and a B. If you pull out an AB, what are you left with? If I pull out an AB out of this, what's left? It's a B. And then if I pull out an AB out of this, what's left? An A. And then lo and behold, before you cancel though, obviously A can't equal 0, B can't equal 0, but what else can't happen? Someone pounced on this like a tiger first hour. B can't equal A, you're like that person in first hour. Nice, in this cat class. How appropriate. And then, of course, I could take this A and cancel it with this A. This B and cancel it with this B. And if you are writing that in your notes, get out, go to the weeds. I'm just kidding. You can never take part of a binomial and cancel with something else. So that is the final answer. So you make a choice. The second one, we could have done what we did in the first example and gotten the same answer at the end. Okay, so now I'm done. You do your homework and get ready for tomorrow.